function, we've talked about that a little bit. So bone function, bones give shape to the head, the face, the thorax. It gives shape, it gives support to your, basically to your entire body. Two bones like the pelvis and your lower limbs are also going to provide support for the body's weight. And you notice that on days like, you know, when you're really busy and your legs get tired. Your legs get tired, your arms don't. Your legs get tired because they support your weight, and that's, or hips. A lot of older people that have hip problems, that's because your hips provide a lot of support for your weight. Bones of the skull are very important for protecting everything that's in it. Number one being your brain, eyes, ears, everything else. And your skull is thick. So if you've ever watched on the computer like a brain surgery where they cut into the skull, your skull is pretty thick. It is pretty hard to crack a skull. So there again, very much protection. Rib cage protects your heart, protects your lungs. Shoulder girdle also is involved with that. And then the pelvic girdle pretty much protects some of your abdominal organs and your reproductive organs. Obviously, your heart and lungs are more well protected by your ribs. Body movement. Bones act as levers, which is probably a physical science concept. There's a bar, there's a pivot point or a fulcrum, and usually that fulcrum is going to be some type of joint, an object that is moved against resistance, and then a force is going to supply energy. In the skeletal muscular system, the bone is going to be the bar, and the joint, like I said, is the fulcrum. The object moved is your body part, and then the force comes from your muscles actually contracting. So bones act as levers or levers, they can also be pronounced. But like I said, that's kind of a physical science term. Just remember the bone is the main bar part, and joints are usually the fulcrum. And here you can kind of see. So if I want to lift a dumbbell, I'm in the weight room. My force comes from my biceps contracting, and that actually is going to pull on my radius, and that force is going to pull up whatever you're lifting. The fulcrum is the point that it moves at, so it would be your elbow joint in that case would be the fulcrum. Opposite, when I'm bringing my arm down, my triceps muscle is going to contract, and that is going to be attached to like the bottom part of your elbow, and that's going to bring the arm down, and that's how muscles typically work in opposite directions. Blood cell formation produces blood cells. Hematopoiesis is the actual scientific term for making blood cells. First, they're going to be formed in a yolk sac, and then they're later manufactured in the liver, the spleen, and finally formed in the bone marrow. So specifically, blood cells, red bone marrow is most important in production of blood cells. Two kinds of marrow occupy the medullary cavities and the larger central canals. Red marrow, spongy bone. Red marrow, spongy bone. So red marrow is going to be found in spongy bone of all of your bones. It functions in the formation, just like I said, red blood cells, white blood cells, platelets. Its color comes from the oxygen-carrying pigment hemoglobin. So blood drive last Friday, they test your hemoglobin. and the color of it comes from oxygen. Your blood inside your body is not actually blue. If it is highly oxygenated blood, it's going to be a bright red, and that's why when you bleed, your blood is always red because it contacts oxygen in the air. But inside of your body, you have blood vessels that have a lot of oxygen and blood vessels that don't. The ones that aren't going to have a lot of oxygen will be more of like a purplish red. The reason your veins look blue is because your skin kind of gives it that color. So you really do not have blue blood inside of your body. Yellow marrow stores fat, and that's pretty much found in the medullary cavity. And if you've ever made a steak, and when the steak is raw and in the center of that bone it's very, very fatty, that would be yellow marrow. Yellow marrow is very much like fat. Storage is another function. Extracellular matrix, that outside dense part of the bone, is rich in calcium, calcium salts. Calcium phosphate is probably one of the main components that makes up your bone marrow. If you look at like coral, zoology, when we're talking about coral, when a living coral dies, the hard piece of coral that's left is from types of calcium also. So calcium salts, specifically calcium phosphate, are stored inside of your bones. And they are very important for metabolism and all of your metabolic processes. Calcium in the bone is a storage, a reservoir for extra calcium. So when your blood levels are low on calcium, your nervous system, muscular system needs calcium ions in it. When these blood levels are low, osteoclasts, so they break down. Osteoclasts are going to break down some of that calcium so it can be released. And then it'll be released from the bone, and then it can be used by the blood system. The parathyroid hormone is very important for regulating your amounts of calcium. Still storing things, calcium stored under calcitonin. So like we said, blood levels, your amount of calcium in your blood levels are very important. So when the opposite happens, I have too much calcium for some reason, calcitonin is going to cause calcium to be stored instead of released. Magnesium, sodium, potassium, carbonate. So potassium carbonate, magnesium carbonate, more salts that are stored in your bones. Bones can also accumulate harmful toxins. So lead poisoning, lead can get into your bone cells. Strontium's kind of something newer than lead. But some of these toxic elements can get into your bones and stored, and that's not a good thing. Here just shows the homeostasis of calcium. This would be negative. This would be under negative influence. Because if I have too much calcium, it is going to produce calcitonin, it's going to store calcium, it's going to come back to normal. If I don't have enough calcium, I am going to have osteoclasts that break down, it's going to release parathyroid hormone, and calcium levels are going to increase and go back to normal. So there is just one example of homeostasis in your bones. And I will stop there.